In this video, I'm working two more sample problems. Let's start with AII 1. So the first task is to reconstitute the schema from this mood and figure. So we will do that. So the conclusion is an I, so that means the conclusion is sum S is P, minor term, major term. The first figure means that we know the M's go in this shape, the subject of the major term, predicate of the minor term. So we fill in the major term, the minor term. Now we know the quantity and quality because of the mood, so that is going to be all M is P for the major premise, and sum S is M for the minor premise. So now we have the schema of this argument. All M is P, sum S is M, therefore sum S is P. So now we're going to construct a Venn diagram to test the validity of this schema, or mood and figure. They're interchangeable. So as you can see, I've already got step 0 on the whiteboard. We have the empty schema for a syllogism, minor and major across the top, middle term down below. So step 1, shading. So what we have is a universal. So remember, we only shade for universal propositions. So we have a universal as the major premise. So what we need to do is shade for the proposition all M is P. So we will shade the region of M outside of P. Again, we are ignoring the S circle because it's not involved in the major premise. So we just shade the region of M outside of P, whether it is or isn't an S, we don't care. So when we think about the minor premise by itself, we have an X that indicates the S that is an M. So we have to put that on the diagram. So notice the region where it would go is this overlapping region between S and M, right? Just as it is here. So what we'll do is we'll put an X here. Why? It's a definite X because of the shading. So notice it has to go in that region of S overlapping M, but because of the shading, we know that it goes in the portion of the region that isn't shaded, because shading means empty. So now, let's consider the Boolean and Aristotelian interpretation problem. So when do we have a potential conflict of the Boolean and Aristotelian interpretations? Only when you have universal premises, all of them, universal, and a particular conclusion. We do have a particular conclusion, but we have one particular premise, which means they're not all universal, which means there can't be a conflict of the Aristotelian and Boolean interpretation. So that means it's perfectly fine for us to use the Boolean interpretation and not put any X's for this universal proposition in the major premise. So that means our diagram is finished just as it is. So the question to ask then is, does this diagram, as it is, require the conclusion to be true? So look at where the X is in the diagram. It does, in fact, require that there's at least one S that is a P, and so this argument form is valid. Now, let's talk a moment about the X that is an S that's also a P. It didn't get on the diagram because we put an X to represent an S that's a P. Rather, this X actually got on the diagram because it represents an S that is an M. In other words, it comes from this minor premise. But it just so happens that because of the shading, there's nowhere else for it to go in that overlapping region, except in a region that also happens to be in the P circle, which means however it got there, there has to be at least one S that is a P, and consequently, this argument is valid. All right, excellent. So now let's move on to our other example, which is III 1. Very similar. So we'll just go ahead and practice the reconstituting the schema. So we'll have sum S is P, as we had in the previous one. First figure again, so the M's are going to be in that shape. major term in the major premise, minor term in the minor premise. Now the mood tells us what the quantity and quality will be. So that's sum M is P, sum S is M. So there's our schema. Sum M is P, sum S is M, therefore sum S is P. All right, step 0 is the empty schema. We've already got that in front of us. Step 1, shading. Well, notice we have two particular premises, which means there is no shading. We only shade for universals, so there's no shading. So the next thing for us to look for is definite x's. Are there any definite x's? Well, we need an m that is a p. So we need at least one m that is a p, which is going to go in this region. The problem is we don't know whether it goes in this side or that side of the S circle. So that's not a definite x. Now, what about sum S is M? It's the same problem, only with S and M. You've got the overlapping region. X has to go in here, but we don't know whether it goes in this or that side of the P circle. So we've got the same problem. So all we have then are indefinite x's, and that's the next step. So we have two. We have an indefinite x for the m that is a p. Since we don't know where it goes, we have to indicate that we don't know where it goes by putting it in the region of m overlapping p, but on the fence formed by the S circle. And similarly, the indefinite x in the in the minor premise, the S that is an m, goes here for the same reasoning. We know it has to go in the region overlapping S and M, but the problem is we don't know whether it is in or out of the P circle, so it's an indefinite x as well. Now, here's an interesting question for us to consider. Why would it not be proper for us to just use one x here and skip the two fence-sitting x's? And that's a legitimate question, because it might be the case that one of these x's, as it were, fell off the fence into the region where that circled x is. But the problem is it doesn't have to be the case. In other words, it could very well be true that both of the x's went this way. In other words, they moved away from the region that circled x is in. So what this really tells us is that we don't have enough information to know that the x in the circle has to be in that region. All we know is that we have two x's that are both indefinite, which means we don't know exactly which region they go in between two adjacent regions. One sits on the S fence because it represents an m that is a p. The other sits on the P fence because it represents an S that is an M. So now the diagram is complete because we've gone through our steps. The schema, universals need shading, didn't have any shading. Definite x's, we had no definite x's. Indefinite x's, they were both indefinite. Because they're both indefinite, there is no definite x to do double duty for some other x. So our diagram is complete. Does the diagram as it stands require that there is at least one S that is a P? That's exactly where that circled X would have been if we had been justified in putting it on the diagram, but we weren't because we didn't have enough information to know that there had to be an X in the region where the circled X was. So this tells us that while it might be true that sum S is a P based on this diagram, because one of the fence sitters could slip over into that region that would make at least one S is a P true. It's only a might. It doesn't have to be true. Since it doesn't have to be true, this diagram does not require this conclusion to be true, and so consequently we say that it's invalid.